Hi everyone, this is Mrs. Han-Baral. Hope you're doing well. Today I'm doing a video on rational numbers and more specifically converting from fractions to decimals and vice versa. But before we go into that, I thought I would just do a really broad overview of the number system. So real numbers are all irrational and rational numbers, basically all the numbers that we deal with. And rational numbers, of course, include any numbers that you can write as a ratio. You see the word ratio in rational. So that would obviously include fractions like 3/4. It would include decimals like 0.5, which of course is 1/2. Percents such as 30%, which of course can also be written as a ratio, 3/10, and so on. But it also includes repeating decimals. So something like 0.3 repeating is also considered a rational number because it can be written in fraction form. 0.3 repeating is, of course, 1/3. And I'll also mention that it includes negative numbers as well. So it could be negative 7/8 and so on. So what is irrational then? So irrational numbers cannot be written as a ratio, and there's special numbers like pi. So pi day just passed, and you know that pi has an infinite number of decimal places that are not in a pattern. And then the other category of irrational numbers that is typically referred to are roots that are not of square numbers. So of course I could put square root of 64 under the rational column because the square root of 64 is of course positive or negative 8. But if I had the square root of 3 or the square root of 17, if I were to punch that out on my calculator, I would see as many decimal places as the screen would allow, but they wouldn't be in any pattern at all, and they do in fact go on forever. The last category is integers, which of course are any numbers that are on a typical number line, so positive and negative whole numbers and 0. So of course I'll include 0, -7, 4, you get the idea. I've also included the symbols for each of these sets of numbers just because sometimes those come up in different contexts. So if you were ever to see something like this actually means the set of all real numbers. So now we'll go on to our examples. So for the first example, we need to convert 7/8 into a decimal, not using a calculator. So don't forget that a fraction is just a division problem, right? I mean, think of the most simple fraction that you know, like 1/2. That's just taking one thing and dividing it into two parts. So same here, I'm just going to take 7 and I'm going to divide it by 8 and just do long division. Of course, 8 does not go into 7, so it's going to be 0, which makes sense because 7/8 is less than 1 whole. So I'm just going to add a decimal after the 7 and put as many zeros as I need to solve this problem and keep my decimal point in the same place value. So now 8 goes into 70 8 times, and I'm just going to go through and do my long division, carrying down the 0 when I need to. 8 now goes into 67 times, and fortunately I can see that it is actually a terminating decimal, so it ends. So 7/8 is equal to 0.875 or 875 thousandths. The next example is a mixed number. It's 7 and 3/11ths. But I really don't have to do anything to the 7 at all because I know it's going to be 7 point such and such. So all I have to focus on is the 3/11ths. So I'm going to do the same strategy that I just did. It's 3 divided by 11. And I'll add some zeros here. Put my decimal. 11 goes into 3 twice. 11 goes into 87 times. Okay, so now 11 goes into 30 twice, and now I can see that it's a pattern. 11 goes into 87 times, and I can see that that 27 is going to keep repeating. So my answer would be 7.27, and I would just be sure to put the bar over 2 and the 7 to indicate that both numbers repeat. My next two examples are converting decimals into fractions, which I personally think is easier because you just have to think about the place value. So 84 this goes to the hundredths place. So if I wasn't going to say negative 0.84, I would say negative 84 hundredths, and that's actually giving away how to write it in fraction form. It is negative 84 hundredths. The only thing is now I have to put it in simplest form. So to do that most efficiently, I would look at the numbers 84 and 100 and find their greatest common factor, which in this case is 4, I believe. So if I then divide the numerator by 4, I would get negative 21. And if I divide 100 by 4, I would get 25. And sure enough, the fraction in simplest form is negative 21/25. My last example is a repeating decimal. So I have 0.1 repeating. So those of you from earlier in the year probably remember that I showed you a little calculator trick, and if you divide 1 by 9 on a calculator, you actually get 0.1 repeating, and if you divide 2 by 9, you get 0.2 repeating, and 3 by 9, you would actually get 0.3 repeating, which I have here. So 0.3 repeating is 3/9, which of course can be simplified into 1/3, and so on. So knowing that trick, 0.1 repeating, well, I can just say that it's 1/9. But I did want to show you how you can actually get that mathematically without a calculator. So what you would do is you would say x equals 0.1 repeating. And now I've turned it into an equation that I can manipulate on both sides. Now I'm going to multiply both sides by 10. And if I do that, I'm going to get 10x is equal to, multiplying by 10 is just moving the decimal lengths over, 1.1 repeating. Now why did I do that? Because now I can actually subtract my original equation. So I can subtract x equals 0.1 repeating to my new equation. 10x minus x is 9x, and 1.1 repeating minus 0.1 repeating actually cancels out the repeating part of the decimal, which is why I did it, and I get 1. And now 9x equals 1, I can just solve by dividing by 9 on both sides, and voila, x is equal to 1/9. So hope this video helps, and I will talk to you all soon.